Assalamu alaikum wa rahmatullahi wa barakatuh. Bismillah ar-Rahman ar-Rahim. We'll start today, inshallah, with some warming up questions to make sure that you understood the material that we covered in the first two lectures. So quickly, which of these is a machine learning application? So I will give you one by one and tell me whether this is a machine learning application or not. Okay, please just raise your hand if you want to answer. The first one, face recognition. Is that a machine learning application or not? What do you think? How can we know that this application is really a machine learning application or needs machine learning? Let's think about this question first. How can we know that this application is a machine learning or not? Anyone? We learned from the past, right? So the application will need machine learning if we think that this application should learn from examples, should learn from the past, from previous, from labeled examples or examples in general. Okay, so does it learn from experience? Does it need to see examples or train from examples? Right. So if that's the case, then we can say that this is a machine learning application. Okay. Right. Face recognition. What is the task of face recognition? Given an image, I want to detect or to recognize faces. I want to say, okay, this is the face of Tamer, this is the face of Ahmed, this is the face of Madiha, and so on. Okay, so this is face recognition. Do we need actually training data for that? If so, if you think so, then this is a machine learning application, right? So what do you think? Is that a machine learning application or not? Face recognition, based on that. Okay, but if it's just analyze the face, then we don't need machine learning. We need maybe image processing. But does it need to be trained? That's the question. Yeah, so we have to have examples of people, right? Of images of people, so that it can recognize the faces, right? So it needs training data. So it is a machine learning application. So it will learn. As I give the machine more examples, it will learn to do better on the task, right? So this is predicting the future based on the past, or predicting the unseen based on what it has seen. Okay, another example, finding the shortest path between two addresses. I have two places, that street to that street. I want to go from that street to that street, and I want to find the shortest path between these two addresses. Is that a machine learning application or not? What do you think? To find the shortest path, do I need to train the system? Why should I train the system? If I have the map already, then I know that I know, and I can have an algorithm, of course, to find me the path between these two addresses, right? But do I need training data for that? So we have to have the map, and we have to have unless you are learning a map, that's a different story. Okay, yani, building a map is a different task. We are not talking about that task here. In that task, we have a map already, of course, and we want to find the shortest path between 2 points. Okay, in that case, we don't really need to train anything. It's just an algorithm that will, given the map, it will find me the shortest path. Okay, so this is not a machine learning application. The next one, finding the fastest path between two addresses. So I have two now places. It's not just the shortest path, it's the fastest path, of course, in terms of time. Okay, so what do you think? Is that a machine learning application? Do we need to be trained here to know which path is fastest? So how would you know that this path is fastest now? Sometimes the shortest is not the fastest, right? If it's crowded, if the speed limit is not يعني is different, if there is an accident, all of this, right, affect the time of the day, right? Is it a rush hour or not? There are many factors that affect the time, right, between to go from one place to another, right? So we need to train here the system on different situations, different conditions, okay? Maybe in different times of the day, different crowds, different seasons even. Sometimes the schools are open, sometimes are not. So it depends, right? So different times, different situations, the system should be trained on that, right? So in that case, this is a machine learning application. Because of the time, we will move to the next one. I will leave the others to you, okay? So think about them. Which type of machine learning is the following task? So I will ask about some tasks and tell me what type of machine learning, okay? Last time we talked about supervised, unsupervised, and reinforcement, and under each sometimes we, for example, the supervised, we said we have regression, we have classification, right? So tell me for some of these following tasks, with what type of machine learning are these? The first one, let's take the first one here. Predicting the price of a new house. I want to predict the price of a new house. What type of machine learning is that task? It is regression, right? Okay, why is that? We have to give a real value because we are talking about prices here, okay? And of course, regression is a type of or a subtype of supervised learning. Very good. The second one, which is already there, a machine playing football. I want a machine to learn to play football, okay, like a robot, okay, that plays football. What type of machine learning is that? Among the three that we discussed supervised, unsupervised, and reinforcement, right? So which type you think is that task? Yeah, there are many steps, and each step you have to make a decision based on the environment, right? Based on others, right? And you get reward or penalty. So it is a typical example of reinforcement learning. Okay. For the sake of the time, I will just pick another one. Predicting the gender of a person. Okay, maybe from the social posts. Okay, so if I look at your tweets, then I should predict whether you are male or female. What do you think? Which machine learning type is that? It's a classification problem, which is under. We need to know, given this timeline, this is a male, and give that timeline, this is a female, and so on. So so we need label data. So this is a classification problem, which is a supervised learning problem. Okay. Any questions from the first two lectures before we switch to the new one? Actually, I think I should shorten a bit the warming up questions so that we don't take a lot of time. But I hope that these kind of questions reiterate or reinforce what we covered in the previous lecture, so that you make sure that, inshallah, that you understand what we discussed. Okay, then let's switch to the new topic. We are still in the introductions, but we will start with the first learning algorithm, and first learning model that we will discuss, which is decision trees. So why we cover decision trees first? Three quick reasons for that. First one, decision trees are very classic and logical to learn. It's very natural. It's very intuitive, as you will see. It is easy to reason about. Okay. The second thing is that it is easy to understand. And once we build a decision tree, it is very easy to understand how we can use it, okay, and how we even built that tree. The third reason is that it is very related to a concept that is commonly used in computer science called divide and conquer. What do you mean by divide and conquer? If we have a big problem, we tend to divide this problem into smaller sub-problems, okay, and then try to solve each of these small sub-problems. If we do so, then we can combine the solutions of these sub-problems to solve the bigger problem. This is called divide and conquer concept. And we do that in our normal lives, right? Usually when we have a big task, we divide it into smaller tasks, and then we try to tackle each of these smaller tasks before we say, okay, now we have a complete solution to the bigger task. Okay, so this is called divide and conquer, and you will see in how we build the decision tree is an example of a divide and conquer concept. Okay, so it is easy to understand, it is intuitive, logical, and it is an example of divide and conquer that we see in many cases in computer science. Right. What is a decision tree? What is a decision tree? That's, of course, should be the first question. And to answer this, we will go through an example during this lecture and probably the next lecture also. In this example, in this problem, we want to, given a day, we want to know or to predict whether we should play tennis in that day or not. Of course, playing tennis is usually outdoor, so that will depend on the weather of the day. Okay, so we should look at some attributes of the current weather and then predict whether we should play tennis on that day or not. Okay, of course, when we say we mean that we want to build a system or a model that will help us make such prediction. Okay, so that's the problem. That's the example problem that we will use to discuss how we can build the decision tree and how we can use it. What kind of attributes in that example for the weather? We have 4 attributes. We have what we call the outlook, whether it's sunny, overcast. Overcast means cloudy, or rainy. Okay, so this feature has 3 values: sunny, overcast, and rain. The temperature is a second feature, whether it's hot, mild, or cool. Humidity is the third. It might be high, it might be normal. And the wind is the fourth. It might be weak or strong wind. So we have 4 attributes here. Now, based on the attributes, the values of these attributes in any day, I want to predict whether I should play tennis on that day or not. Okay, so that's the definition of the problem. Of course, this is a classification problem, right? An example of classification, because we have 2 classes here. We want to predict whether to play or not. So we have 2 classes, yes or no, play or don't play. And this is, of course, a classification, and more specifically, it's a binary classification because we have 2 classes only. So it is an example of classification, which is supervised learning, of course. In supervised learning, we have to have training data with labels. So we would expect in the training data that we have different days, right? Because the example here is a day, right? We want to predict for a day whether we should play or not. So every example should be a day. For each day, we have values for the attributes. So we would expect that we have 4 values because we have 4 attributes. And then we have a label that says we should play on that day or not, so that we can build a learning model. So that we can train a model that will predict in the future. So here is a typical training data. As I said, we have different examples. So in this data, we have actually 14 examples. Each represents 1 day. So you will see that this is just the ID of the day. Let me change the pointer. This is just the ID of the day, and we have each column here is an attribute. So there is an outlook attribute, a column, there is a temperature, humidity, wind, and then the label. So for example, for that day, it was rainy, the outlook was rainy, the temperature was mild, the humidity was high, and the wind was weak, and the label for that day is that we should play tennis. Okay. Another one is sunny, mild, high, weak, and we should predict for that day that we shouldn't play tennis. So that's the training data. Okay. Now, how can we classify a new day? Here is how decision tree will work. Here is an example of a decision tree. How will I classify a new day? How can I predict if I will play tennis or not? I will do that by asking questions about the attributes of the day, about the weather. Okay, so for example, I will ask a question about the outlook first. What is the outlook for that day? Is it sunny? Is it overcast? Is it rainy? These are the possible values for the attribute outlook. Okay, now of course I assume that here I observe the I know the values, of course, right? So for a given day, of course I know what is the value for each attribute, but I will check, is it sunny, is it overcast, is it rainy? Now if it is overcast, which means cloudy, then this model will predict that yes, play tennis on that day. So just from one question, if the weather is cloudy, if the outlook is overcast, then yes, play tennis without any further questions. But if the outlook is sunny, for example, then I will ask another question. What is the humidity value? Is it high or normal? What is high and normal? These are the possible values for humidity. Okay, so if it's high, then I will predict no, don't play tennis on that day. If it's normal, then play tennis. Similarly, if the outlook was rainy, then I will ask about, in this case, about the wind. Okay, if the wind is strong, then I shouldn't play tennis. If the wind is weak, then I should play tennis. Okay, this is one way of classifying. You might think that way. Ask questions, and based on the answers, you might ask other questions, or you might make a decision or a prediction. Okay, what you see in front of you is called a decision tree. It's one possible decision tree. Of course, you can think of many others, but this is one possible decision tree. Why is it called decision tree? Decision because we are making decisions at the end, at the bottom of the tree. We call this the leaves of the tree. Okay, at the leaves of the tree, we are making decisions, and we make decisions based on the answers of the questions. Why is it called a tree? Because it looks like a tree, right? It has a root node at the top, and then it has branches, and each internal node has branches, and so on. So it looks like a tree. So we call it decision tree. Tree that will allow us or will enable us to make decisions based on the answers of the questions that we ask. Okay, more formally, decision trees have three things. They have internal nodes, nodes that are not leaves, like what? Like this node, like that node, like that node. These are called internal nodes. They are not leaves. And these are the questions that we will ask. Each internal node is a question about an attribute, but we call it in machine learning a feature. So an attribute in machine learning is called a feature. So outlook here is a feature. Wind here is a feature. Humidity here is a feature. Okay, and you'll see in decision trees, we ask questions about features. Every internal node is a question about a feature. Type. How about the branches? The branches are corresponding to the values of that feature. So for example, the feature outlook has 3 possible values. So there will be a branch for each value, because we don't know which answer will be, right? It might be sunny for one day, it might be overcast for another, it might be rain for a third. So there will be a branch for each value of the feature. Humidity has 2 branches only because it has 2 possible values, which are high and normal. So the internal nodes are about features, the branches are about feature values. The third one is the leaves. The leaves. This is a leaf, this is a leaf, that's a leaf, that's a leaf. Okay, leaf doesn't have any branches, right? So the leaves are the classification decisions that we make, or the labels that we will predict. Okay, so that's the representation of a decision tree. So for that tree, we ask first about outlook. If it's rain, then we ask about the wind. If it's overcast, we say directly that yes, play tennis. If it's sunny, we ask about humidity. If it's high, then we predict no. If it's normal, it predict yes, and so on. So that's an example of a decision tree. Decision trees also can be thought as functions. So given a complete example, give me an output, which is whether I should play tennis in this case or not. Okay, so the function takes inputs and provide output, right? The mathematical function, the functions that we know, any mathematical function takes parameters or inputs and provide an output. In this case, we have 4 inputs which correspond to the 4 attributes or 4 features. We will no longer say attributes. I think after this lecture, we will always say features, and we will always say feature values. So we have 4 features here, and the function, of course, takes 1 value for each feature and then provides the output, which is whether we should play tennis or not in that case. Any questions so far? Any questions? Type. Let's see an example of prediction. Let's say that we already have this decision tree, and we are given this red example. Okay, the outlook is rain, so we have specific day in which we observe these values for these features. We have a rainy outlook, we have hot temperature, we have high humidity, and we have weak wind. What should we predict? Should we play tennis on that day or not? How can we use this decision tree to make the prediction? So that should be the prediction now, based on the values of the attributes. It was rain outlook. So outlook is the root. So we start from the root. We ask about the outlook. Outlook is rain. Then with the second question here is wind. So the wind is weak. So we go through this branch. Then this is the prediction. So the model here predicts that yes, we should play tennis on that day. Okay, if we change it this week to strong, if in another day we have rain, hot, high, strong, then we go to rain again, and then the prediction will be low because the wind is strong. Okay, so this is how we make predictions in decision trees. Given that we have the tree, we can make the prediction going through the tree top down. Okay, starting from the root, we ask the question, and based on the answer, we go through the branches. Okay, type. If there is no question about that, what do you notice from that specific tree? Do we use all the attributes here? Did we use actually all the attributes? Actually, no. You will see that there is outlook, there is humidity, there is wind, but there's no temperature, for example. Okay, so that tree doesn't ask any question about temperature. It doesn't. So it means that for that tree, temperature is useless. It doesn't matter whether it's hot or not. Playing tennis doesn't depend on whether the temperature is hot or not, or normal or cool for that tree. okay, for that decision tree. And other decision trees might might have a different structure, right? So that's something to notice. Another thing, you see that in different branches we might ask different questions. So it's not always the case that the first question will be outlook and then the second question will be humidity. It depends on the branches. Each branch is different. So here we ask about humidity. Here we ask about wind. It can happen. Of course, you might start to think, how did we get this decision tree, right? How would we decide which question should we ask when, right? So all of these questions are really good and we will discuss them inshallah later today. But this is just to notice that branches are different, okay? Right, let me ask you another question. Can we, after we, general question, okay, not maybe on that decision tree, but in general, do you think that in one path, so we call this is a path, right? This is, and this is another path, and so on. In one path, should we or can we repeat questions? For example, can we go outlook wind then outlook again? Should we do that? What do you think? Is it possible to do that? And is it logical to ask about outlook, then wind, then outlook again? Of course, there is no point in repeating questions because we already asked the question, we already know the answer. So we should not do that. So in every path, we have different questions. And as you see, we might have different questions. We might even not ask about all features, right? So temperature is not there. It might be in one branch and might not be in other paths. So each path might be completely different from the other paths. Fine. Now a quick exercise just to to show you how powerful decision trees are. We can, as I said, decision trees are functions in general, right? So we can build actually decision tree for Boolean functions. So if you remember the intersection function, for example, if I have two Boolean variables, A and B, and I want to compute the intersection, okay, I can represent that function by a decision tree. How is that? Decision trees need features, right? So the features here will be the values. Let me change this to a pen again. So what are the features that we have here? Yeah, let's focus on this example. So we have A and B, right? These are the values, the features that that we have in that function. So let's say that we will start with A. So we'll ask about the value of A first. Okay, we want to build the decision tree for that function. What do you mean by that? At the leaves of the decision tree, we should say what will be the value of the function. Type the function the intersection function is true or false, right? So the output of the function is true or false. So I want to build a decision tree that will tell me, based on the values of A and B, whether the intersection is true or false. So I will ask about A first, for example. Now, how many branches I should have here? It depends on the possible values of A, right? A is a Boolean variable, so we have only two possible values. It's true or false, right? Now, if A is false, then should we ask about B or not? What do you think? We shouldn't,
I think
right? So what should we do here in the tree? It will be false. So we should predict false immediately,
mm,
right? Should predict
yes.
false. How about if A is true? What should we do? Very good. So then we ask about B. If B is, so B can be true or false, right? So
Yes.
if B is true,
Then
sorry,
it's true.
I made a mistake here. I made a mistake. It shouldn't be the leaves, right? It should be on the branches. So these are the values of B. So if B is true, what should be the prediction? What should I do? It would be true because both A and B are true. If B is false, it would be false. Very good. Okay, so that should be false and that should be true. Okay, so that's a decision tree for that function, for that Boolean function. Of course, you can also think about the others. I will leave the others as an exercise for you. Okay, let's get back to our playing tennis example. And now I think the question is, how can we learn a decision tree from the data? So we know now what we mean by decision tree. We know now how can we make predictions using a decision tree. What is remaining is how we can learn that tree. How can we build that tree? Okay. Of course, because this is um, um, a, a supervised learning task, we need training data, right? So we have to learn the decision tree from the data, from the training data that we have. Right. What do you mean by learning in this case? Remember last time when we talked about learning, we said that learning is represented by a learning model, right? And the learning model is a set of parameters. Okay, so we have to have values for these parameters, and that's what we will get from the data. In decision trees, the parameters are three types of parameters, or three things we need to learn. First, what are the questions that we should ask? Which features we should ask about? That's it. The second one is what order we should ask these questions on. Okay, so the first one, which features we should focus on, we should ask about. The second one, with what order. The third one, what are the decisions that we should make at the end after we ask some questions? What are the decisions? How can we make, we assign the labels at the leaves? So these are the three things. Okay, what questions to ask, what order we ask them, and what answer or what label to predict at the leaves when we have enough questions. These are the three things that we need to learn in a decision tree. Let's see how we can do that. Again, the terminology is questions correspond to features, answers correspond to feature values, and classification at the leaf correspond to the labels that we want to predict. How? First, we need to understand that we have so many possible decision trees, right? The one that we saw is just one of them, but we might build many others. If that's the case, what should we do? Should we try every possible decision tree and then pick one of them? For that example, we have hundreds or maybe thousands of these possible decision trees just for this very small problem with 14 training examples, or actually 4 attributes only. Okay, so it's not feasible, it's not efficient to go through every possible decision tree. We cannot do that exhaustively. So we have to find one. We have to pick one decision tree without going through all possible decision trees. For that case, we will use a heuristic greedy search algorithm. Okay, what do you mean by greedy algorithm? I will show you by example. Let's say that you are on the street by your car, you are driving your car, and you are in that line. Okay, let me change again the pointer. You are in that line, and you find besides you a line that is shorter. What would you do? What do we always do in that case? We leave our line, right, and join the shorter line. That's typical, right? This is called the greedy algorithm. That's greedy because we think only local. We think now. Okay, I saw a shorter, as you see in this example, there are trucks. Okay, there are trucks, and the trucks are much slower than the cars that were in front of you. So you probably better to stay in that line, even though it is longer. But what you have done is just greedy. You thought about the length of the line only. You took only one factor in making your decision, which is the length of the line, but you didn't consider other factors. When you do that, it's called making local decisions, not global decisions. You made a local decision. You just were short-sighted. You only thought about the length of the line. You didn't think about the speed of the cars in that line. Maybe because you don't know actually the speeds, or maybe you didn't notice. Even if they look like these cars, it might be slower, right? But you don't know. It's not a global decision. You didn't know you didn't consider every factor in making your decision. Okay, just local factors, just small number of factors. This is the idea of greedy algorithms. Okay, so in building the decision tree, we will use a greedy algorithm. Okay, we make local decisions. We'll make one decision at a time, one step at a time. Okay, how we will do that? We will pick the questions to ask in order. We will just first think what is the best possible question to ask now. And after you pick that best one, you pick another one, and then you pick a third one, and so on. How will you make a decision that this is the best or not? You will make a question, you will pick a question that will maximize the accuracy, that will maximize your the correction of your decisions. Okay, of course we will discuss more details inshallah, but that's the general idea. We pick a question that will most probably give you correct decisions in the future. After you select that question, then you select another question. Based on what? Based on looking at the other possible questions and picking the one in using a greedy algorithm that we will inshallah discuss. Okay, and so on. So that's the main idea. How will we start this? We will start by just one question. If I could ask just one question, what question would I ask? So we will just simplify the task. Instead of thinking of complete decision tree, no, I will think only about asking one question. If I have only the chance to ask one question, which question should I ask? Which question actually I should pick, depending on how good each question is. So I should pick the best question, right? What do you mean by the best here? The one that will make my decisions the most accurate, that will make as many correct decisions in the future as possible. How can I know the future, right? Of course, that will depend on the past, will depend on the training data that I have. If I pick that question, will I make good predictions or not? If I pick that question, will I make better prediction or not? And I check the features this way, and then pick the one that will give me the best decisions in the future. Okay, now I pick that, then I turn to pick another one, and so on. So that's divide and conquer, right? The first one, ask only about one question. Think as if the decision tree is only one node, is only the root. Okay, and think which question you should ask. If you ask this question, then you divide, you split the problem into the branches. Okay, we'll of course talk about the detail inshallah today and in the next lecture inshallah. So the idea here is that we want to find a feature that is most useful in helping you guess whether to play tennis or not, in helping you making good decisions, correct decisions. Okay, so that's the idea. How to select the best feature? There are many ways. One way that we will discuss inshallah in class is accuracy. Accuracy means how many of the decisions that you made were correct versus how many were not correct. What is the percentage of your decisions that are correct? Okay, that's how we will select the best feature. We'll check this feature will give me 30% accuracy. This feature will give me 70% accuracy. This feature will give me 50% accuracy. Then I should maximize. I should pick the feature that will give me 70% accuracy. Okay, that's why it's called greedy. It look only one question at a time, assuming that the decision tree is just one node. Then after I decide on that node, then I go to the branches and repeat what I did based on the branches. Of course, the details we will discuss inshallah. How we will measure how good the feature is, as I said, we have different ways. One way we will discuss in class, which is classification accuracy. The other ways like entropy and others, inshallah, you will see in the exercises. Okay. Type. I don't think we will have time to go through the details today, so I better stop here and ask you if you have any questions. Next, inshallah, lecture, we will go through exact details based on the training data that we have, how we will pick the questions and how we will pick the order of the questions and how we will make decision that, okay, this is enough, we should stop at this branch. And that branch, no, we should ask more questions and so on. Inshallah, we will see that these details next time.